An overheated 200 amp main can stem from several potential issues. Firstly, consider a loose neutral in the meter base. A loose neutral connection may cause the hot wire to carry more current than intended, leading to overheating. Inspect the neutral connections at the meter base and any distribution panels, ensuring they are tight and free from corrosion. Secondly, a faulty main breaker could be to blame. A main breaker that is failing might not trip correctly, thus allowing excess current to flow through the hot wire. To test the main breaker, reset it and carefully monitor the amperage draw. A faulty breaker might either fail to trip when it should or trip prematurely. Thirdly, wire damage may contribute to the problem. Damaged wires can increase resistance, and this increased resistance generates heat. Closely inspect all visible wires for any signs of damage, paying particular attention to bends and points where wires pass through walls or other structures. Fourthly, an overloaded circuit is a potential cause. If the circuit served by the 200 amp main is drawing more current than it's designed to handle, the hot wire will likely overheat. To check for an overload, determine the amperage draw of all appliances and loads on the circuit. If the total amperage exceeds the breaker's rating, you'll need to reduce the load by disconnecting some appliances or redistributing them to other circuits. Fifthly, the main breaker might be incorrectly sized for the actual load. If the main breaker is undersized relative to the circuit's load, the hot wire will be prone to overheating. To determine the correct breaker size, carefully calculate the total amperage draw of the circuit and compare it to the breaker's rating. If the breaker is too small, it needs to be replaced with one of the appropriate size. To systematically troubleshoot this, follow these steps. 1. Confirm the amperage reading. Use an ammeter to verify that the 200 amp reading is accurate. This will help ensure you're working with reliable data. 2. Check the neutral connections. Thoroughly inspect all neutral connections, both at the meter base and any distribution panels. Look for any signs of looseness or corrosion, and tighten or clean the connections as needed. 3. Test the main breaker. Reset the main breaker, and closely monitor the amperage draw. If the breaker fails to trip when it should, or if it trips prematurely, it is likely faulty and requires replacement. 4. Inspect the wires. Carefully examine all visible wires for any signs of damage. Pay particular attention to connections and areas where wires pass through walls or other obstacles. Replace any damaged wires promptly. 5. Check the circuit load. Determine the total amperage draw of all appliances and loads connected to the circuit. If the total amperage exceeds the breaker's rating, reduce the load accordingly. 6. Determine the breaker size. Calculate the correct breaker size based on the circuit load. If the existing main breaker is undersized, replace it with one of the appropriate rating. Always observe critical safety precautions. Before performing any electrical work, always turn off the main breaker to de-energize the circuit. Use proper safety equipment, including insulated gloves and a face shield, to protect yourself from potential electrical hazards. If you're uncomfortable working with electricity, or if you're unsure about any aspect of the troubleshooting process, it's always best to contact a qualified electrician. Working with electricity can be dangerous, and it's crucial to prioritize safety above all else. Remember these steps. Firstly, check the neutral connections. Secondly, test the main breaker. Thirdly, inspect the wires. Fourthly, check the circuit load. And fifthly, determine the breaker size. Understanding the potential causes can help you systematically troubleshoot the issue. It's important to remember that electrical work can be dangerous, so always prioritize safety and consult a qualified electrician if you're not comfortable performing the necessary inspections and repairs yourself. Start with the simplest checks firstly, looking for loose connections and obvious signs of damage before moving on to more complex testing procedures.